Let's see now a simple example with the entire process of a flat slab. So we start by giving a name on the new project. We define initially some general parameters and then we start by modeling. So we can start by inserting the sections of the columns. Use the snap on the grid. We can insert the sections of the columns. Then we define a new level and we decide the connection method of the columns node with the mesh surface, because in this level it will be the flat slab. We can use copy level, go up to the first level and paste the sections of the columns. Now in the first level we have to define the external boundary of the flat slab. So we use lines to define the external boundary. Here we need to take care to exclude the column sections from the external boundary. So we start use polyline, the snap commands, and we design the border of slab excluding all border columns. After we finish, we go again on modeling, and now in the surface elements command, we select 3D mesh and we define the flat slab parameters. So we give a description, it will be a plate, we define the density, the width and the thickness of the slab. New and OK. After that, we need to define the external boundary. We can just click on a line and right click, and when the lines that define the border are closed, the program automatically recognizes the area and asks me to define the mesh group. Okay, and now I can see that my flat slab mesh contains a mesh group. Now we can open the calculate window and we can calculate the meshing of the flat slab. Before this, we need to click on creating holes in the columns location, so the program automatically will recognize the columns inside the slab and will create a hole in that point. So I select the mesh, I click on this command, and I can see now that there is a parenthesis with a number that gives me the information that there will be a hole in the position of the internal column. So calculation, and the meshing is ready. Next step is to calculate the mathematical model. So in tools, calculation, and the mathematical model is calculated. After the mathematical model calculation, remember always to go back to the surface elements command in calculate and press the auto button. That is very necessary for the good orientation of the surface elements. Then exit and finish. The next step is the load application. Select loads, the 2D view, and then insert on the entire slab, dead and leave loads. Select plate and pressure. Type the value of the dead load, insert, then select leave load and type the leave loads value. Then press OK and use edit by pick to see the values. Next step is analysis. You can create static scenarios and run the analysis. Before, remember to delete the rigid link constraint. There is no need when you use the surface elements. Select static analysis and run. After that, you need to create the combinations. You can use, for example, one combination, 1.2 of the dead loads and 1.45 for the live loads, and save them as static scenarios. In members design, in a Eurocode scenario, when in parameters we're going to select and calculate the combination that we saved previously. In members design, we can find the flat slabs commands. First of all, we have to define the parameters, and that means combine the right layers. And inside these layers, we have to design the corresponding lines. First of all, we need to define in flat slab layer the outline of the flat slab, including external columns, and corresponding to the layer flat slab. For convenience, the first thing is define the flat slab layer as current, select all layers, make them not visible and not editable, excluding flat slabs and also the concrete columns, so we make them visible and editable. Okay, and now we can select polyline, flat slabs, and design the external boundary, including also the external columns. Respectively, we can design the draw panels. So that means select again the polyline. This time as layer we select draw panels, and we design the area around the columns of the slab, relieving the fatigue from drilling. Same procedure for the rest of the columns. Next thing is to design the support lines in X and in Z direction. So we select line. This time we need to define the lines in support lines in XX. We make it editable and visible. Okay. So we select support lines and we start design the support lines in X, and then the support lines in Z. So now we save and we go back in members design again, and we can be sure that flat slabs belongs to flat slab layer, draw panel is in draw panel layer, and the same for the support lines. After this, we can do the calculation of the design strips. According to Annex I of Eurocode 2, flat slabs is divided into design strips. These are the areas that are automatically created by the program in both sizes. Each design strip is divided into sections along its length, perpendicular to the support line. In its direction, Scada integrates the internal forces of finite surface elements intersect. By completing these, occurs the bending moments around the axis of the section. Select diagrams in both directions and see the corresponding diagrams. The results command opens the results file through the report. Each page concerns a strip line, initially described the characteristics of the strips, then displays the reinforcement results on the top and on the bottom in details for each zone, divide them into sub-zones. The latest version of Scada Pro contains also the punching checks. In accordance with Eurocode 2, the checks is part of the check and design process of the flat slabs, which runs automatically, but can also run as individual check of any column. All data can be set automatically or even manually. Selecting by pick with the left mouse button, show the node of the column and right-click to open the dialog box where you specify all the necessary parameters. In this example, we select the node number 10, and in the combinations field, we can choose combination or user. In the first case, the program finds automatically the combination that gives the worst axial resulting, displaying delta n with the corresponding moments. If you choose user, enables the user values for axial moments in their respective fields. There are also other parameters to specify before doing the punching calculation. All these parameters are explained in the respective manual and example. So let's see. We click calculation and we open to see the results. So in the first page of the results shows the input data as well as the reinforcement layout, and the second page shows the check results and also the detailing results. The third page offers a design that gives all the necessary information for the distances between the punching reinforcement in order to understand all the results.